When you try to shove too much water through a pipe, it can fail, resulting in a leak. The same is true when trying to push too much current through a PCB trace. Only in the case of a PCB, the leak is in the form of heat. One of my favorite YouTubers, Carl Bugeja, is very familiar with those limits. That's why it's important to know how wide a trace needs to be for a given current. In order to calculate the trace width needed, we need to know how much current is required, the thickness of the copper trace, and the maximum temperature rise acceptable. Fortunately, we don't have to solve this by hand. I like to use an online calculator like this one from EE-Web. I'll leave a link in the description if you want to check it out. Anyway, let's say I need a trace to support a maximum of 1.5 amps with a copper thickness of 1 ounce, which is the most common thickness. Let's also assume a maximum temperature rise of 10 degrees Celsius. We don't want the board to get too hot. So we need a trace width of at least 20.7 mils. Let's go over to Flux and change the trace width. I'll select this entire net and add the trace width layout rule. I'll round up to 22 mils, and the net changes accordingly. Of course, this rule will apply wherever I set it. For example, if I wanted to change all the traces on this board, I could easily apply the trace width rule to the layout as well. While this method of setting traces works, there is an easier way. By opening this context menu next to the net, I can select one of a few default traces, or press W to cycle through them. Of course, we can change the default trace widths by adding the Preference Trace Widths rule to Layout. Now we can enter as many different trace widths as we want, making it easy to change any trace in our project. And that's about it for this video. If you learned something, tell me about it in the comments and subscribe for more content like this.